If this is the first time you're watching my video, well, welcome dear viewer. This is a series where I take a look at one of the flat earth flyer and discuss/debunk one section at a time. So far we covered water is a natural level, airplane level flights, science says is stationary, horizon is always eye level, we see too far, dome is real, and moonlight is cold. This video is all about crepuscular sunrays. The sun is smaller than Earth and very close. We can trace the angle of rays back to their source above the clouds. The sun is clearly not massive or 93 million miles away, but small and relatively close. Now, I always try to see things from the other person's point of view, but I still can't figure out how this is a proof of flat Earth. Anyway, I digress. Let's ignore everything else that is wrong with that statement. Let's start with angular distance. Let's imagine a wall exactly perpendicular to your eye of sight and at the exact center. For this example, we'll ignore other variables like curvature, refraction, and such. Given the distance between you and the wall, with the wall's width, we can calculate this angular distance by using Pythagoras. So given the distance as adjacent leg, where opposite leg is half the width, we can calculate adjacent angle, which is half of angular distance. So if this wall was 1,000 meters away and 100 meters in width, our adjacent angle would be around 2.86 in degree and the angular distance would be 5.70 degree. Now, how wide does that wall need to be if it was 10 kilometers away to have the same angular distance? Well, it would be 1 kilometer in width. Let's look at it in reverse. A wall 10 kilometers away with a width of 1 kilometer would look the same size as a wall only 1 kilometer away with a width of 100 meters. Call me stupid, but I don't see how from an angular distance we can figure out the length. But that is just the beginning. We Globers say it's the refraction and Earth's curvature that causes the sun to appear larger when near the horizon. On a flat Earth model, for you to be able to observe a larger sun, based on their assumption on this paragraph, must surely mean that sun is closer to you at that point. Again, on a flat plane, if the sun is closer to you when it is at horizon, then it means the people between you and the sun must see it much, much larger, right? It feels like one section of the flyer you want to have the cake and on another section you want to eat it. You can't have it both ways. So what causes these crepuscular sunrays? In gaming we call this God ray, which I think sounds way much cooler. Well, simply put, God's ray happens when sunlight passes through the air with a bunch of stuff in it. The white light coming out of the sun is really made of all the colors of rainbow, and what makes them all different is really the wavelength. The longest wavelength we see look red to us, where the shortest wavelengths appear blue or violet. When the light passes through our atmosphere, thanks to the abundance of nitrogen and some oxygen, short wavelength lights are scattered more than others. Much of the remaining wavelengths, when mixed together, still appears nearly white, while the blue and violet scatters and dominates the sky. Some of the violet light is absorbed by the upper atmosphere, and our eyes are less sensitive to violet than blue. Thus, the sky appears blue. But when the sun is near horizon, Well, the light has to travel through more air, so the blue and violet are scattered even more and allowing the red and yellows to pass straight through to our eyes without all the competitions from the blues. This is the same reason, closer to the horizon, the sky fades to a lighter blue or white. Now, God's ray happens when the sunlight hits bigger particles like dust and water, which bounces all the light's color pretty much the same. Thus, most of the God's ray looks white. When the God's ray isn't white, like during sunset, well, simply it means that the color wasn't white to begin with. Apart from the dust and water particles, we also need something to block the sunlight. Without it, we wouldn't be able to see the paths of individual rays. Lights would just be bouncing off everything equally. Cloud just happens to be denser pockets of water vapors and dust that are great at blocking sun. But you can get trees and other structure blocking the sun in a similar way. But areas around cloud tends to have some dust and water, and when sunlight manages to break through the cloud, well, it would hit a bunch of stuff to have it scattered. Glorious God's ray. If you manage to view it when the sun is at the horizon, well, you will get to see God's ray that stretches all the way across the sky. Like all God's ray, they look like they are being radiated from the sun, and the rays going behind you? Directly opposite the sun is where they all seem to meet, as if they are being radiated out from some invisible sun. The rays that are going behind you is called Anti-Crepuscular rays. So what is happening? Well, as the sun is so far away that when the light hits Earth, all the rays are virtually parallel, and thus God's rays are also virtually parallel. Now, I have talked about perspective in greater length on one of my earlier flat earth debunking videos. Sue me as I can't remember which one. Long story short, if you look at a straight train line, though the tracks are parallel, they seem to get closer and closer at distance. Imagine the God's ray, parallel and behaving the same way, and appearing to be radiating from the sun. And this is the same reason why anti-crepuscular rays seems to be radiating from an invisible spot opposite of the sun. So wait, if what I'm saying is correct, that would mean if we could see the God's ray from outside the Earth's atmosphere, it would look parallel, right? Exactly. This picture was taken by an astronaut on the International Space Station, provides an unusual viewing perspective from above a God's ray and shows the true nature. They really are parallel. The photographer in me, oh yes, in case you didn't know, I used to be a photographer. I even have a portfolio video in this channel. So that me wants to shout out about polarizing filter. But let's not. Well, that's all for this video. Thank you so much for watching. If you have enjoyed this content, well, a like and a comment won't go amiss. If you'd also subscribe for future contents like this, it would definitely help my small channel grow and would be thoroughly appreciated. Have a safe day. Signing off.